So if you'll take a look at your math packet, page 67, we're going to start a section called Graphing Quadratic Functions. So I'm going to go over just the terminology first, and then I'm going to break it up, and each video will be a video on how to find a particular part of the quadratic. Okay? So a quadratic function is in the format of f of x equals ax squared plus bx plus c, where a does not equal 0. So remember, this is a standard format of a quadratic function. We're going to write it in descending order. So x squared, x, and then no x. A is our term next to our coefficient next to the x squared. B is our coefficient next to the x, and c is our constant. So every quadratic function will be written in this format. A quadratic function has a graph called a parabola, and the parabola can either go down, so it opens down, or it can open up. So it depends on what our a value is, determines whether it opens up or opens down. This point right here, when it opens down, is called the vertex, and this is our maximum. When it opens up, the lowest point is called our minimum, and that is also the vertex. Okay? Now, a parabola is symmetrical. So if I put a vertical line right through my vertex, you can see, and you have to pretend because it's my drawing, you can see that it is the same on both sides. So this point here is the same distance away from the vertical line as the other side. So it's symmetrical, and it is symmetrical about the x, how do I want to put this? The x term of the vertex. Okay, so the vertex is a point. The vertex has an x and a y value. The x value determines what's called the axis of symmetry. Okay, so in this one, when it opens up, your axis of symmetry, again, lines up with the x value of your vertex. All right, another term that you're going to need to know is the y-intercept. Okay, so it's where it crosses the y. In this case, it crossed it down here. So the y-intercept is when your x value is 0. So it's just like when we did linear equations. The y-intercept is when x was 0. And then we also have x-intercepts. So if you notice, you will have two x-intercepts. That's what we've been doing when we've been factoring and using the quadratic equation, or quadratic formula, sorry. We've been finding these values, the x-intercepts, where it crosses the x-axis. So an x-intercept is when y is 0. And with most parabolas, you have two. There are some cases that you only have one x-intercept, and that's when it comes down and touches the x-intercept and then goes back up. So I'll explain to you when you'll see that. Then there's also where you have a parabola that goes away from the x-axis. So this is where our complex number system comes in. So this is where you'll end up with an I in your answer. So you have x-intercepts, you have a y-intercept, you have a vertex, and you have an axis of symmetry. You also will have the domain and the range. So the domain, again, is our y or x values, excuse me. Domain is always the x values. With a quadratic equation, the domain will always be negative infinity to positive infinity. Okay? The range is the y values. So the y values will be the y value of your vertex. So it depends on if it opens down or opens up. So in this case, if it opens down, it is going to be from negative infinity to the y value of your vertex. When it opens up, it's going to be the y value of my vertex to infinity. So it depends on what your parabola looks at, is going to be determined by the vertex, and if it opens up or it opens down. Okay, so that's just an introduction. We do have one more term that we're going to look at in our introduction, and that is called the determinant. So the determinant will identify how many zeros, x-intercepts, roots. So all three of those terms. So we have zeros of the polynomial. You have roots of the polynomial. And both of those terms are the x-intercepts. You can think of it as when y is 0, you have an x-intercept. Where your graph roots where your parabola roots or is stationed, is connected to your graph, those are the roots of the polynomial. They're just intercepts, x-intercepts. So all three of these terms can be interchanged: x-intercepts, roots, and zeros of the polynomial. So to determine how we find how many we have, or what kind of roots we have something called the determinant. So this should look very familiar to you. Oh, spelled it wrong. Okay, the determinant. So the determinant is your b squared minus 4ac. This should look familiar. This is within the quadratic formula. So remember, the quadratic formula was negative b plus or minus the square root b squared minus 4ac all over 2a. The determinant helps us find out how many roots we're going to have. So if our determinant is less than 0, that means it's negative, right? So remember, if the quadratic formula, if this value is less than 0, that means it's a negative value. What you're going to end up with is complex answers, complex numbers, which means you're going to have two imaginary numbers. Okay? In other words, if you had the square root of negative 25, so let's say your determinant, which is the number underneath your radical, is a negative 25, you're going to have plus or minus 5i. You're going to have two complex numbers, or two imaginary numbers. That's when your determinant is less than 0 or negative. All right? If your determinant equals exactly 0, all right, it's exactly 0. So for instance, if I had the square root of 0, which is 0, what you're going to have is one real root. Oops. Okay? Because this is 0, that means all we're going to deal with is the first part of our quadratic equation. If our determinant is greater than 0, which means it's positive, you have a positive value, you're going to end up with two real roots. So for instance, if underneath my radical, if my determinant was, let's say, 36, right? And let's just say that this is our quadratic equation. Well, because this is positive, I'm going to end up with 2 plus or minus square root of 36 is 6 over 2. So I have a positive version. 2 plus 6 is 8 over 2, which is 4. 2 minus 6 is negative 4 over 2, which is negative 2. Those are my two real roots. So the determinant allows us to identify how many roots are we going to have. Is it going to go away from my graph, my x-axis, so I don't have any crossing because I have an imaginary number? Am I going to have one real root, which means it bounces off? Or am I going to have two real roots, which means it crosses in two places on my x-axis? So those are some terms that you're going to need to know before we get into the graphing.